Okay, here are solutions to practice quiz 11. We're looking at an ellipse to start with. First, we have to work on completing the square, so I'm going to gather the x terms together. I need a perfect square there, so I'm going to complete it with a constant. Then I'm going to gather the y terms together. Remember, that 2 has to be factored out, so this is going to be negative 6y, because if you distributed that, you get negative 12y. We need a constant term equals 0. And then if you add something in to the left, that's just fine as long as you add it in on the right also. Okay, so what is that? Divide 8 by 2, 4 squared. That's adding 16 to the left, add 16 to the right. Negative 6 divided by 2 is negative 3 squared. That's 9, but I didn't add 9 to the left. I added 2 times 9 to the left. Now I'm adding it to the right. So I made this so it's a perfect x plus 4 square. I made this so it's a perfect y minus 3 square. You could double check that if you wanted. On the right, 16 plus 18 is 34. But I need a 1 to get it in standard form, right? Standard form is the key. So I'm going to divide everything in sight by 34. That puts a 1 over there. Gets this as x plus 4 squared over 34. This, it has 34 divided by 2, so this has 17 downstairs. Okay, so this is standard form. Notice this coefficient is bigger. That means that's the a, and the major axis is going to go along the x direction. So a equals square root of 34, b equals square root of 17. If I wanted c, remember what we do is a squared equals b squared plus c squared for ellipses. So root 34 squared is 34, root 17 squared is 17, plus c squared. 34 minus 17 is 17. C is going to be root 17 also. Okay, so now we're ready to do vertices, covertices, and foci. But you have to start at the center. And so even though it doesn't require the center, you ought to start thinking about the center. Negative 4, 3 is the center. Where are the vertices? Well, the vertices start at the center, and because the major axis goes with x's, we're going to go right and left, so negative 4 plus or minus root 34, 3. The covertices go up and down, so negative 4, 3, and then up and down root 17. And then the foci, that has to do with c, is negative 4 right and left along the major axis, 17, 3. There we go. That's all the stuff on the first one. How about the next one? Well, here we're going to do something similar, but let's just put in the center at negative 1, 1, a focus at 2, 1. Just to highlight, if you have the center and a focus, you actually have C already, that's 3, distance from the center of the focus. A vertex at 4, 1. If you have a vertex and the center, you already have A, right? So if you wanted to, without really doing any more work, I could say, hey, the other focus is at negative 4, 1. The other vertex is at negative 6, 1, right? And so really you could sort of knock out vertices and foci just like that. Now, I tend to think more in terms of the equations here. So think about this. You got a squared equals b squared plus c squared. We happen to know that this is 5 squared. B squared I don't know. C squared is, let's see, 3 squared. So 25 minus 9 is 16, is b squared. B is 4. B is the distance to the co-vertex. So, oops, that's not 4 up. Got to go 4 up. There's 4 up, 4 down. 1, 2, 3, 4. So the ellipse is going to go through the vertices and co-vertices. Okay, so how do I write those? Well, I have a tendency, you can write them, they're points. So you could write the vertices as 4, 1, negative 6, 1. Or you could write them as the center, negative 1, 1. and then go plus or minus 5, just to highlight they're balanced from the center. Where's the co-vertices? Negative 1, 1, plus or minus 4. Where are the foci? Negative 1, 1. We're going right and left 3, right? And that's just another way of writing it. The major axis, of course, goes through the foci and vertices. The minor axis goes through the co-vertices. And the equation, right, since the major axis is right and left, x minus negative 1 squared over something plus y minus 1 squared over something equals 1. Well, what's A? A is 5 squared, B is 4 squared, and there I'm set, right? So let's see if I can get on to the third problem. Okay, so what are the vertices? Well, here it's just so much easier to write them down the other format. So I'm just going to write 1, 2, 1, negative 2, right? It's perfectly acceptable to write them, and they're just listed there. What are the foci? 1, 3, that's that point. 1, negative 3, right? What's the transverse axis? Well, it's pretty clearly the line x equals 1. What's the equation? Well, here you need the center. And notice the center is the midpoint between the vertices. So the center here is 1, 0. And notice it opens up and down. So that's going to be y minus 0 squared over something minus x minus 1 squared over something equals 1. That is the form of a hyperbola going up and down, centered at 1, 0. Now, this has to be A. Notice I have the distance from the vertex to the center. I have the distance from the focus to the center, which is 3. For hyperbolas, it's c squared equals a squared plus b squared, right? So c squared, that's 3 squared. A squared is 2 squared. I need to figure out what b is. Let's see, 9 minus 4 is 5. B is going to be the square root of 5. So this is the square root of 5 squared. This is 3 squared. What are the asymptotes? Well, the asymptotes for vertical is x minus whatever equals y minus whatever. It's got to go through the center, right? The asymptotes have to go through the center. So x minus 1 equals plus or minus b over a. What's b over a? B is root 5. A is 3, right? Okay, one problem to go. Let's see, I need to standardize this. So minus 2y squared plus 4y, make sure that distributes to negative 8y, plus blank equals negative 1. What do I have to put in here? 4 divided by 2 is 2 squared. So 2 squared, that is 4 times negative 2. That balances the equation. So I've got x plus 1 squared minus 2, y plus 2 squared equals negative 1, negative 8, negative 9. Divide everything by negative 9. Now here, because of the negative, the signs are actually going to change. This is going to be the positive term, right? Y plus 2 squared is the positive term, and multiplying by 2/9 is the same as dividing by 9/2. This will now be the negative term, x plus 1 squared over 9 equals 1, okay? So the center is kind of the easiest part here. X is negative 1, y is negative 2. The center is negative 1, negative 2, right? My a, right? My a term is 9/2. Oops, sorry, my a term, a squared is 9/2. So a is square root of 9/2, or 3 over root 2. B is just 3, right? And I kind of need c. So c squared equals a squared plus b squared. That c squared is 9/2 plus 9, which is 27/2. So c is going to be the square root of 27/2. Certainly you could simplify that if you wanted to. So how am I going to go about doing this? Well, the vertices are the center, negative 1, negative 2, plus or minus a, right? Plus or minus 3 over root 2. There we go, which is just a little bigger than 2. So the vertices are actually going to be like there and there, right? And the foci are going to be along those same lines. They're going to be -1, 2, and that is substantially bigger than 2, plus or minus the square root of 27. Make sure I'm doing this right. 27 halves, right? And then the transverse axis is the one that goes through the vertices and the center, right? Well, what's the equation? This is a vertical one, so it's going to be y plus 2. I don't have to reinvent the wheel. It's sitting over here, right? 9 halves minus x plus 1 squared over 9 equals 1. And what are the asymptotes? Last but not least, well, it's up and down, so I've got x plus 1 equals plus or minus b over a, y plus 2. Now, what is b over a? b over a is 9, square root of 9 over square root of 9 halves, right? Or if you're dividing by a fraction, you can invert and multiply. So that's root 2 over 3. Those cancel, and you actually get root 2. You can go back and watch that again and make sure I'm doing it correctly.